Welcome back, recruits. Your clearance for Phase 2 is accepted. Today's mission is Operation the Derivative, covering AP Calculus Unit 2, Topics 2.1 through 2.4. This intel is classified Recruit Eyes Only and makes up 10 to 12% of your exam. Let's begin. Here is your situation report. Up to this point, you've relied on algebra static intel. Algebra analyzes the parked car. It requires two distinct points to calculate an average velocity over a completed trip. Calculus provides dynamic intel. It analyzes the exact moment of impact. Our primary objective for this operation is to deploy the limit to close the gap between an average rate and an instantaneous rate. We begin with Tactical Drill 2.1, Long Range Recon. This is the difference quotient. You know this as the slope formula. Graphically, it represents the slope of the secant line intersecting a curve at 2 points, a f of a and x f of x. This action measures the average rate of change. It's a solid baseline, but it's not precise enough for our current mission. Tactical Drill 2.2, Closing the Gap. We deploy the limit as h approaches 0, forcing the distance between our two data points to shrink to nothing. The secant line locks onto a single point, transforming into the tangent line. Status: instantaneous rate of change achieved. Memorize this protocol. This is your primary directive, the formal definition of the derivative. It is the source code of calculus. The trigger is the limit as h approaches 0, shrinking the interval. The slope is the difference quotient representing rise over run. Together they acquire the target f prime of x, the instantaneous rate of change. Communication protocols are strictly enforced. You must decode and use proper notation. Prime notation, like f prime of x or y prime, is Lagrange style, used for brevity to speak directly to the function. Differential notation, like dy dx, is Leibniz style, showing the actual ratio of change between variables. Critical intel: dy dx is a noun meaning the derivative, while ddx is a verb commanding you to take the derivative. Do not drop your mathematical grammar. Moving to visual recon. Your target here is local linearity. If you zoom in far enough on your scope, every smooth curve eventually looks like a perfectly straight line. The derivative is simply the slope of that line at that exact coordinate. Field intel, estimating from tables. If command asks you to estimate f prime of 3 from a data table, you bracket the target using the closest surrounding inputs, in this case, 2 and 4. Mandatory protocol. You must write out the uncalculated difference quotient structure, like 12.8 minus 11.2 divided by 4 minus 2. Show the setup to earn the point. Field intel, reading the terrain. When reading a graph, the derivative translates directly to the steepness of the hill. If the graph is climbing, the slope is positive, meaning f prime of x is greater than 0. At the exact peak or valley, the terrain levels out, meaning f prime of x is equal to 0. If you are descending, the slope is negative, meaning f prime of x is less than 0. These are your rules of engagement regarding differentiability versus continuity. If a function is differentiable, it implies it is continuous. Think of the road analogy. If you can drive smoothly at 60 miles per hour, the road must exist. However, warning, continuity does not imply differentiability. Just because the road exists doesn't mean it isn't full of potholes or impossible hairpin turns. Hazard detection protocols are active. There are 3 primary threat zones where derivatives fail to exist. Threat 1, sharp turns, where slopes violently clash. Threat 2, vertical tangents, where the slope becomes infinite and unmeasurable. Threat 3, discontinuities, where the road is completely broken. If you encounter these, there is no derivative. Let's conduct a threat analysis on the ultimate corner case, the absolute value of x. Approaching from the left flank, the slope is locked at -1. Approaching from the right flank, the slope is locked at +1. Collision detected at the origin. Because the left-hand derivative does not equal the right-hand derivative, this is an ambush point. The derivative is strictly undefined at the sharp turn. Tech protocols for calculator usage. When authorized to use your calculator device, the command is dependent on the model you use. Consult the specs for the model you have been assigned. Precision standards dictate that you must store all intermediate values to avoid rounding errors. Your final answer must always be correct to 3 decimal places. You can reach that answer either by rounding or by truncating. After action report. Phase 2 debrief. Mission accomplished if you can confirm the following. You know the limit definition of the difference quotient. You can visualize the slope of the tangent line. You can estimate derivatives from tables by showing the setup. You can identify the three hazards where derivatives fail. And you understand the logical flow that differentiability requires continuity. Phase 2 is complete. Clean your gear and prepare for your next mission. Derivative rules. Status: dismissed. For more AP Calculus worked out free response question solutions, like and subscribe to get your FRQ on.